Okay, so in this section, we will look at some applications of static electricity. So static is more useful than just rubbing your feet on the carpet and zapping your little brother or sister. So the first application we will look at is lightning. So what happens in a cloud to cause electrons to move from some particles to others? So what's happening in the cloud is there are strong updrafts in the center of the cloud that carry smaller raindrops and ice particles up. At the same time, gravity causes larger, heavier rain and ice particles to fall. This causes collisions, so friction and contact of the particles and electrons to be transferred. What part of the cloud is most negatively charged? The bottom part of the cloud is most negatively charged. So what happens is you see that the negative charges are along the bottom of the cloud, and then the surface of the ground gets an induced positive charge. So we've talked about induction. So because the ground would be neutral, but the positive charges will align themselves at the point where there's a concentration of negative charge. So question 3 says, what happens to the surface of the ground when there is a thundercloud overhead? An induced positive charge occurs on the surface of the ground. So what safety precautions should be taken when lightning is close by? Avoid hiding under trees, open fields, being on a lake or in water. Take shelter in a building and avoid windows. So some people have what's called a lightning rod on their homes or buildings. What is the purpose of a lightning rod? It says that twice, I don't know why. Let's get rid of that. A lightning rod is a metal sphere or point attached to the highest part of a building and connected to the ground. It has two purposes. 1, reduce the likelihood of a lightning strike, and 2, to conduct the charge safely into the ground. So that's essentially what you need to know about lightning. Lightning is caused because of friction of particles in the cloud. Induction is caused on the surface of the earth, and then lightning occurs it's like a spark. So it's the same thing as when you rub your feet on the ground and then touch a doorknob or your little brother or sister. So there's a discharge of electrons. Excess electrons have been created because of friction. Electrostatic series, we know about that. And then they'll be discharged to the highest point. So this is why the tree here would be most likely hit by lightning, or high buildings. So that's one application of static. Other ones are using an electrostatic precipitator. So an electrostatic precipitator is a type of cleaner that removes unwanted particles and liquid droplets from a flow of gas. So maybe you have one of these in your home. If you have like an air cleaner that plugs into the wall, it works on the same premise as this. So dust and liquid particles become positively charged when they come in contact with a wire that has a strong positive charge. This picture here does not indicate a wire, but some have that wire. They are neutralized when they collide with the negative collection plate and are collected in large trays called hoppers. So in this case, this particular one has a negatively charged metal grid, and you see that you've got waste gases containing smoke particles. They pick up a negative charge, and then there's a positively charged collecting plate, so it's attracted to it, so then the gas comes out and it's clear. Second type is called electrostatic spray painting. So this is used for virtually any industrial painting, cars, furniture, and so on. So the paint leaving the gun is given a negative charge, and the car fender is given a positive charge. So they're oppositely attracting, and therefore all the paint will go onto the item instead of being sprayed all over. So if you see the way the spray is coming out, it would just continue on its trajectory. But because of the charge, it's all attracting to the item. So this is environmentally and economic because it reduces overspraying. The third type is photocopiers, photocopiers, laser printers, and scanners. So these all work on the same premise. They use the principles of electrostatics. So there is negative toner, and it's attracted to the positive dark areas representing the areas to be copied. So if you see here, inside the photocopier, the drum here is positively charged, and there's a replica of the image being left, and the negatively charged toner is attracted to the drum, and the positively charged paper attracts the toner. And of course they cover over with a little bit of plastic at the end so that all the image does not fall off the page. All right, and the last one we're going to look at is called a radiation dosimeter. So maybe you have a family member that works in the healthcare field, and you've seen that they have a little on their badge. They probably have a radiation dosimeter attached to them, and that measures the amount, detects the amount of radiation that the person's been exposed to. So that's it. Those are some applications of static electricity.